In this video, I will solve question number 1 to 10 of the exercise 13.1. So actually this is from 15th edition, Thomas Calculus 15th edition. There is not much difference between Thomas Calculus 14th edition and 15th edition. In 15th edition, they added 2 to 3 chapters after chapter number 16, which is 17, 18, or 19, I guess. So our aim would be to solve all the questions in detail, and I will solve these questions by splitting this into smaller portion. So we start with exercise 13.1. In exercise 1 to 4, it has been asked to find the limit of the function. So the solution is we apply the limit on all the components. Limit t approaches to pi sine t by 2i plus limit t approaches to pi cos 2 by 3 tj plus, let me just change the settings like this. Now this will be fine. So I'll get more space out of that. Okay. Plus limit plus limit t approaches to pi tangent 5 over 4 t k unit vector. So first of all, we solve this the first case. It is sine pi by 2 sine pi by 2i plus cos 2 pi by 3. We apply the limit j plus tangent 5 pi by 4 k unit vector. Sine pi by 2 is 1, so we get I unit vector plus cos 2 pi by 3. It is 2 multiplied with 80 divided by 3, so we have 120, and we can write this as allied angle pi by 2 plus pi by 6, and when we add pi by 2, it is in second quadrant, and we change cos into sine, and there we have sine, so it will be sine pi by 6, and cos was negative over there in the second quadrant, so sine pi by 6j plus. And similarly, you can find the value of tangent 5 pi by 4 from the calculator if you like. So this will be tangent 5. If you will check in calculator, you will get tangent 5 pi by 4, that will be equal to 1. So that is k unit vector. So I unit vector minus sine 30 is 1 by 2, so we have minus 1 by 2j plus k unit vector. Remember that you don't need to apply the allied angle. If you don't know the allied angle, it is fine. You can use calculator. Calculator is usually allowed at this stage. So simply use the calculator. So that is the answer for our first question. Let me just solve the second question. So this is a bit easier. I apply the limit. So this becomes minus 1 q I. Then we have minus pi by 2 j plus natural log of minus 1 plus 2 k unit vector. So I apply limit to all the problems over here. Okay. So we have minus I, then we have sine pi by 2 is 0, 0 j plus natural log of 1, that is equal to 0. Uh, let me see, I'm sorry. Sine pi by 2 is 1. So we have minus j, and natural log of 1 is 0. So this quantity is 0k. So we have minus I minus j as the answer. Question number 3. So we apply the limit. Question number 3. When we apply the limit, suppose we apply the limit. There is a reason I apply limit over here in each component. T square minus 1 natural log of t I unit vector minus limit t approaches to 1 t under root minus 1 1 minus t j plus tangent inverse t, and there should be limit t approaches to 1 tangent inverse t. So this is question number 3. Here you can see that when I apply the limit, you get 1 square minus 1 natural log of 1, and this is 0 by 0. So this is indeterminate form. So we apply the L'Hopital rule first. Applying the L'Hopital rule, limit t approaches to 1, we get 2t and 1 over t. The derivative of numerator and denominator I minus. Same is the case with the second component. When we apply limit, we get 1 minus 1 0, and this is also 0. So we get 1 by 2t under root and minus 1 j plus. So this is simple. We apply limit tangent inverse 1. In first component, we get 2t square. This becomes 2t square. So we have 2i. In the second case, we have minus minus plus 1 by 2j, and the last one, there should be k unit vector, plus pi by 4 k unit vector. This is question number 3 for you. Okay. Question number 4. We apply limit over here, sine t over t, that becomes 1. So we have I unit vector plus. Now we apply limit t approaches to 0 tangent square t over sine 2t j minus limit t approaches to 0 tq minus 8 divided by t plus 2 k unit vector. When we apply the limit over here, tangent 0 is 0, sine 0 is 0, so we need to use the L'Hopital rule over here. So we get I unit vector plus limit t approaches to 0 to tangent t secant square t, and then we have cos 2t, and the chain rule gives us 2 as well. I hope this is correct. When we apply t0 over here, we get minus 8, minus 8, minus 8, I'm sorry, we get minus 8 divided by 2 k unit vector. I unit vector plus, after solving this and cancelling this out, we get 0. Maybe I solve this for you. Limit t approaches to 0. This becomes sine t over cos t, 1 over cos square t divided by cos 2t, j plus minus minus plus, and this is 4k unit vector. I unit vector plus, since sine 0 is 0, cos 0 is 1, so there is nothing that gives us 0 by 0. So we have 0 j plus 4k unit vector, and the final answer is I plus 4k unit vector is the answer. This was question number 4. Now we reach at question number 5. Let me just first read the statement. In exercise 5 to 8, RT is given as a position of the particle in the xy plane at time t. Find an equation in x and y whose graph is the path of the particle. So in fact, we have to convert this into the Cartesian form. Then find the particle's velocity and acceleration vector at the given value. So first of all, from the theory, we know that the first component is x and the second component is y. So we can easily identify the components. X is equal to t plus 1, y is equal to t square minus 1 from question number 5. So from first equation, from this equation, we can write t is equal to x minus 1 and put that value over here. So we have, for example, y is equal to x minus 1 whole square minus 1. So this is equation of parabola. This is parabola. Okay. Now the next thing that we want to show is to find the velocity and acceleration vector. That is a bit easier. For velocity, we can easily find by taking a derivative of position vector I plus 2tj, and for acceleration, we take a derivative of velocity vector. So this is 2, acceleration is 2j unit vector. And it has been asked to find the velocity and acceleration at t is equal to 1. So velocity at t is equal to 1 will be equal to I plus 2j. We simply put the value for t, and there is no t over here, so the answer remains the same. Now we move to question number 6. Question number 6. Okay. The same is the case. First we identify this is x. So x is equal to t over t plus 1 and y is equal to 1 over t. So what we need to do is we need to eliminate t to get the equation in Cartesian form. So x is equal to t will be 1 over y, t will be equal to 1 over y plus 1. From here you can find t is equal to 1 over y. Try to eliminate the value for t, eliminate it by some methodology. So when we solve this, we get 1 over by taking LCM 1 over y, 1 plus y over y. So we finally get 1 over 1 plus y. So this was the equation. This is the equation for Cartesian for above vector valued function. We can find the value for y as well, and the y will be equal to 1 over x minus 1. So this is question number 6. So other thing that is left is to find the velocity and acceleration. So that is a bit easier. I hope you can get it. So I write the answer dr by dt, that is for velocity. And for velocity, first we take a derivative of first term. Okay. And then the second term. So t plus 1 whole square, t plus 1 as it is, the derivative of t is 1 minus t as it is, and the derivative of t plus 1 is 1. This is I, and the derivative of second term is minus 1 over t square j. After subtracting, we get 1 over t plus 1 whole square, I minus 1 over t square j. This is velocity. We need to find the velocity at t is equal to minus 1 by 2. So we have 1 over minus 1 by 2 plus 1 whole square I minus 1 over 2 whole square j. So velocity at minus 1 by 2 will be equal to 4I plus 4 minus 4j, I guess, minus 4j. This is velocity at minus 1 by 2. Similarly, we can find the acceleration. I hope you can find it easily by taking a derivative of that and derivative of this term. So the velocity and the acceleration will be minus 2 by t plus 1 cube I plus 2 by t cube j. And similarly, this acceleration should be defined at minus 1 by 2. We put that value over here, minus 1 by 2 plus 1 cube I plus 2 over minus 1 by 2 cube j. And finally, after putting that, we get minus 16I minus 16j. Okay, so this is the acceleration at minus 1 by 2. Okay, question number 7. since I promised that I will solve all the questions, so either easy or difficult, just stay tuned for this series. X is equal to, here x is equal to e raised to power t, and y is equal to 2 by 9 e raised to power 2t. What we do, we simply uh, square that. X square will be equal to e raised to power 2t, so that we can put that value over here. So we have y is equal to 2 by 9 x square, which is a parabola. The next step is to find the velocity. So the velocity dr by dt e raised to power t, the derivative of first component, it remains the same. Then we have 4 over 9 e raised to power 2t j. Okay. Similarly, the acceleration, or maybe first you need to find the velocity at natural log of 3 e raised to power natural log of 3 I plus 4 over 9 e raised to power 2 natural log of 3j. Exponential and natural log will be cancelled from here, so we can cancel. We do not write the cancellation, but you know that anti-log and log cancel out. So we have 3I plus 4 over 9, and this 2 can be written in the power. Exponential and natural log will be cancelled out, so we get 9j. 3I plus 4j. That is the first answer for velocity. Next is the acceleration. So we need to take the derivative of this equation. Acceleration will be equal to e raised to power t remains the same since it is exponential. Then we have 8 by 9 e raised to power 2tj by using the chain rule. Acceleration at natural log of 3, the t is given over here, natural log of 3 e raised to power natural log of 3I plus 8 over 9 e raised to power 2 natural log of 3j. After solving that, I hope you can solve this easily. E natural log will be cancelled out. 3I, acceleration is 3I plus. Then we can write this as square. This e natural log will be cancelled out, 8 by 9 and 9j. So this 9 cancel, and 3I plus 8j is the answer. So this is question number 7. Now for this part, question number 8, we identify this, the first component, as cos 2t, and y is equal to 3 sine 2t. Question number 8. Okay. So what we do over here, that is interesting. Okay. One thing we can do is, the only thing that I guess we can do is, we write this as y over 3 sine 2t, then squaring both sides, we get x square, maybe something like that, cos square 2t plus sine square 2t, that is x square plus y square over 9, that will be equal to 1. Since cos square theta plus sine square theta is equal to 1. That's why the right hand side is equal to 1. Okay, now we identify the velocity and we find the velocity and acceleration. Velocity is dr by dt minus 2 sine 2ti plus 6 cos 2tj. So velocity at t is equal to 0. This is 0 I. Cos 0 is 1, 6j. So answer is 6j. And we can also find the acceleration. Acceleration at, first we need to find the acceleration. So we take a derivative, minus 4 cos 2ti minus 12 sine 2tj. Acceleration at t is equal to 0. Acceleration at t is equal to 0. Cos 0 is 1 minus 4i minus sine 0 is 0, and this is 0j. Minus 4i is the answer. Okay, t is equal to 0. This is question number 8. So you can see that you need to solve all the questions in detail in order to get the feeling of the theory. So question number 9 to 12, but I will only solve first two questions, 9 and 10, and then I will, in the next video, I will solve the 11 to 20 or 21, something like that. So 9 to 11, it has been given as the position vector of particle moving along various curve in the xy plane. In each case, find the particle's velocity and acceleration vector at the stated times. There are two times given, and this is interesting to sketch them as vectors on the curve. So this is our question number 9. Finding velocity and acceleration is the easier part, but I will do it anyway. So solution, velocity dr by dt cos t I minus sine t j. We need to find the velocity at t is equal to, or maybe first acceleration, acceleration minus sine t I minus cos t j. So this is the velocity and acceleration. First velocity, we find velocity at pi by 4. Velocity pi by 4 gives us cos pi by 4 I minus sine pi by 4 j. Cos pi by 4 is 1 by under root 2, and that can be written as 2 under root by 2 I minus sine pi by 4 is 2 under root divided by 2j. So this is the velocity at pi by 4. Similarly, we find the acceleration at pi by 4. Acceleration at pi by 4 is minus sine pi by 4 I minus cos pi by 4 j, and this is minus 2 by under root 2. Sine pi by 4 is 2 under root by 2 I minus cos pi by 4 is 2 under root 2 by j. You can check it from the calculator. Similarly, at t is equal to pi by 2, we need to find the velocity and acceleration at pi by 2. Velocity at pi by 2 can be given as cos pi by 2 I minus sine pi by 2. Cos pi by 2 is 0 I, and this is j. Sine pi by 2 is 1, so we only get minus j. Similarly, acceleration at pi by 2. Acceleration at pi by 2, where is acceleration? This is acceleration, minus sine pi by 2 I minus cos pi by 2 minus cos pi by 2 j. Sine pi by 2 is 1, so we get minus I, and cos pi by 2 is 0. So acceleration at pi by 2. Now the question is how to plot that, how to plot this term. First, we need to understand that what we get from this position, the position vector. So we get the circle. The first thing that we get the circle, which is already given, but you can also find the r yourself, that by squaring it you can get the same answer. Another thing is that either we are moving towards anti-clockwise or clockwise. What is the orientation? So when we have sine of t in the first place, and you can put some values, for example, when t is equal to 0, r of 0 is sine 0 is 0, cos 0 is 1, you get j. Then you put t is equal to pi by 2. So r of pi by 2 gives us I, and cos pi by 2 is 0, right? Is this true? No, this is not true. Let me just go back again to solve that. R of 0, sine 0 is 0, cos 0 is 1. R of pi by 2, I'm putting all the values over here to get the orientation. Sine pi by 2 is 1 I, cos pi by 2 is j, which is 0j. So it means that the object is moving in this direction. Okay, first you get j, I'm sorry, not in this direction, in the other way around. It is moving in this direction. Okay, so the orientation is, we identify the orientation, it is something like that. And when you take a look at velocity at pi by 4, first of all, you can plot that velocity at pi by 4, I is positive over here and j is negative. So you get something, some value like this. So what you do, you can just copy that and put the value at the point where we have this point over here. First you can identify the point t pi by 4. Sine pi by 4 is 1 by under root 2, 1 by under root 2, and you put t is equal to pi by 4, so it is 1 by under root 2. At this point you have this velocity vector at pi by 4. This point corresponds to t is equal to pi by 4, and this is the acceleration, and this acceleration is at pi by 4. And remember that it is towards the center. How you can plot the acceleration? And acceleration is negative, as you can see from here. It is negative, negative x-axis, then negative j. So it means that it should look like this. So you just copy that and put it, that value over here at that particular point in the circle. Similarly, you can do this exercise for acceleration pi by 2 and velocity pi by 2, and we will see that it is velocity look like this. Velocity is pi by 2. Since velocity is minus j and minus j is over here, you can just copy that vector and put it on that particular point, And similarly, you can do it yourself, find the acceleration, that is pi by 2, and it is towards the negative x-axis, and you can see that it is in the negative x-axis. So the last question of this video is the question number 10. It is the same question, but the orientation is different. First, we find the velocity dr by dt minus 2 sine t by 2i plus 2 cos t by 2j. Similarly, acceleration dv by dt, and we find the acceleration minus cos t by 2i minus sine t by 2j. We find the value of velocity at t is equal to pi and t is equal to 3 pi by 2. Velocity at pi velocity at pi will be equal to minus 2i plus cos pi by 2 will be 0, so I don't write that value. Similarly, the acceleration at pi minus cos pi by 2 is 0, sine pi by 2 is 1 minus j. And also velocity at 3 pi by 2, velocity at 3 pi by 2, velocity at 3 pi by 2. So that is minus 2 sine 3 pi by 4, I guess, plus 2 cos 3 pi by 2, 3 pi by 4 t, no, 3 pi by 4 j. So 3 pi by 2 velocity is minus 2 under root 2 I. You can calculate it from the calculator, minus 2 under root 2 j. Similarly, the acceleration at 3 pi by 2, and that is equal to under root 2 by 2 I minus under root 2 by 2 j. The next step is to display this on the graph, which is a circle, and the orientation is anti-clockwise, since there is cos in I. In the previous question, the first component was sine, but now it is cos. So you can put the value from 0, pi by 2, and so on. You will see that this is anti-clockwise. So the first value we have is something like that, velocity vector, which is at pi, and similarly we have acceleration at pi. You can plot that yourself, minus 2i and minus j. This is in negative y-axis, and this is at negative I-axis. And at another point, when we have t is equal to 3 pi by 2, 3 pi by 2 is 180 degree, so I'm sorry, 120 degree, and then we have this velocity, that is 3 pi by, you don't need to remember that, you first need to plot all these vectors in the xy plane and then copy paste accordingly. For example, in the first case it was easier, minus 2i shows that it should be a vector towards the negative side, so we just copy that and put it over here. Okay, similarly acceleration is on that side, on this side, so we put that value over here. So you can do the same for velocity at 3 pi by 2, and acceleration usually inside, so acceleration is 3 pi by 2 towards the center of the circle. Thank you for watching.